Hello everyone and a very warm welcome to this course. In this series of tutorials, we are going to be looking at deploying machine learning models with FastAPI and Docker. However, this tutorial presents a basic overview of machine learning, i.e. a refresher on the basics or an introduction to the basics of machine learning. So the first thing that we're going to do is we're going to look at the definitions and basic concepts. What is machine learning? It is a branch of artificial intelligence that is focused on enabling systems to learn from data rather than following hard-coded rules. So, machine learning's significance lies in its ability to predict outcomes or identify patterns based solely on historical data, evolving autonomously over time. A foundational understanding of machine learning involves three concepts, three very key elements. The first is representation. Representation defines how knowledge is represented within the model, which might be through structures like decision tree or complex neural networks. And then we also have what we call evaluation. Evaluation metrics like accuracy or prediction assesses a model's effectiveness and provides basis for comparing different models. Then we have optimization, which is an iterative process of adjusting the model's parameters to improve performance. And this is often achieved through advanced methods such as gradient descent or hyperparameter tuning. Let's move on to the next topic, which is machine learning versus AI versus deep learning. So how is machine learning different from AI and deep learning? Machine learning is often confused with artificial intelligence or deep learning, and while machine learning is a subset of artificial intelligence, it has its differences at its core. For instance, while artificial intelligence works to enable machines think and make decisions just as a human would, machine learning trains machines to improve attacks without explicit programming. So artificial intelligence enables machines to think and make decisions just as a human would, based on explicit program. On the other hand, machine learning just trains machines to improve outcomes without explicit programming. AI refers to development of progress by machine learning. Machine learning trains machines to improve without programming. And deep learning is a subfield of machine learning that deals with algorithm-based, essentially, on multi-layered artificial neural networks. So deep learning is basically known for image and speech recognition. While machine learning is similar to deep learning is a subfield which deals with algorithm that is based essentially on multi-layered artificial neural networks. Basically, ML models still need human intervention to make adjustments just in case an algorithm makes an inaccurate prediction. Deep learning models can determine if a prediction is accurate on their own with minimal or no human prediction. Now, we want to look at the types of machine learning. We have three types: supervised, unsupervised, and reinforcement learning. So in supervised learning, the model is trained on a data set where the outcomes are known, allowing it to learn from the labeled data. For unsupervised learning, on the other hand, this involves finding hidden structures in unlabeled data. It is useful for clustering and association tasks. And then finally, we have reinforcement learning, which is unique in that it operates by trial and error, where an agent learns true rewards and penalties. Each of these types is suited for different types of problems and applications, and they are foundational for developing intelligent systems. What is machine learning workflow? Machine learning workflow refers to the series of steps that transform raw data into actionable insights, and the process starts with data collection. Data collection involves gathering extensive data sets from various sources, such as database or live feed. Then we go to data pre-processing, which cleans and organizes the data. This step addresses issues like missing values and inconsistencies and preparing the data for the machine learning model. Then we go to model selection and training. This phase involves choosing the best model architecture for the task. During training, the model processes the data, adjusting its parameters to better capture patterns. And then finally, we have evaluation and optimization, which uses metrics like accuracy and precision to gauge model performance. Through fine-tuning, the model's accuracy and reliability are enhanced, ensuring robust deployment capabilities. What is the impact of machine learning in healthcare, finance, and transportation? To mention just a few. The impact of machine learning is profound across the various industries and in healthcare. Machine learning enhances diagnostic prediction precision, and it optimizes personalized treatment. In the area of finance, machine learning streamlines operation from fraud detection by algorithmic trading, allowing for data-driven financial decisions. Banks use machine learning to assess credit risk and protect customers from fraud through patient recognition. The field of transportation has witnessed major advances with ML in autonomous vehicles and logistic optimization. So companies like Tesla rely on machine learning for self-driving systems, which use sensor data for accurate navigation and real-time decision-making. So, a fully automated vehicle, which has autonomous capabilities and self-driving systems, uses machine learning for navigation and real-time decision-making. If you have a car which is self-automated, how is it able to take you from your starting point to your destination is through machine learning. Now, we look at applications of machine learning. Machine learning applications are embedded in everyday tools and experiences, which drives personalization and improves security. So we have recommendation systems. Platforms like Netflix and Amazon use machine learning to analyze user behavior and suggest content or products based on the relevance to the particular user. Voice Assistant, Siri, Alexa, Google Assistant all use machine learning for natural language pre-processing, and they use continuous learning to improve their response. Then we have social media personalization. Machine learning ensures that users see relevant content. It also helps filter inappropriate materials, making platforms safer and more engaging for users. Lastly, we have fraud detection. Machine learning safeguards financial transactions by identifying unusual patterns in spending, enabling quick response to threats. Machine learning can be trained to detect fraud through analyzing unusual patterns in spending. If you have a bank account, you have a pattern with which you spend. When there's an unusual spending noticed by the machine learning, it is able to detect that it could be a possible fraud. All in all, these are some of the few applications of machine learning, and this is just a brief overview of machine learning. So, when we went through the definition that the machine learning, the difference between machine learning, AI, and deep learning, and we looked at the types of machine learning: supervised, unsupervised, and reinforcement. And then we also looked at ML workflow from collection, pre-processing, training, and then evaluation of the model, and we looked at its impact in some few sectors: healthcare, finance, and transportation. Lastly, we looked at application of machine learning. This gives us a basic overview of what machine learning is. In the next tutorial, we'll go into developing or building and training models using the workflow that we mentioned here, from collection to preparation to pre-processing or preparation, and then training and evaluation. So stay tuned, and thank you.